And welcome to lesson 4.2, solving exponential equations graphically. So this is where you either need a piece of graph paper or graphing technology on a graphing calculator to help you with this. All right, so let's just explore, ladies and gentlemen, the exponential function. Okay? Three things we should know is, first of all, whenever you have an exponential equation, you notice that the x is the exponent. So the x is in the exponent. That's how you can recognize if you have a difference between an exponential, a quadratic, a linear, for example. Okay, so x is in the exponent, so it's raised up. Okay, and with the equation y equals a b to the x, b is your base. It could be a doubling base, it could be a half-life base, and a is your initial start amount, where you start off. So initial value. Okay. So what do we know about b, the base? The base has to be greater than 0. The reason why, folks, is if it is equal, the reason why it can't be equal to 1 is if you have 1 raised to the x, doesn't matter what your exponent is, it will always equal 1. So 1 times 1, 1 to the exponent 1 is 1. 1 to the exponent 100 is 1. 1 to the exponent 0 is still 1, folks. So that's why the base can never be equal to 1. In order for it, it will not be an exponential equation in this case. Okay? Take a look at our next bullet. We have the y-intercept, which is your initial value. If we're taking a look at word problems. Okay, that's A. Domain as the real numbers, set of real numbers, and the range as all real positive numbers. The reason why, ladies and gentlemen, if I scoop down here just to look at the graph, reason why they're all real positive numbers is because we have what's called an asymptote. And currently in the base form here, it is at the axis, the x-axis, which is y equals 0. So the domain always is that x belongs to a set of real numbers, where the range will fluctuate wherever the asymptote is. All right. And taking a look, the horizontal asymptote in this case is y equals 0. Depending on if you do any translations or transformations where you shift it up or down, or if it reflects the x or y axes, things are going to change for that. Okay, so if a is greater than 0 and b is greater than 1, it's an exponential growth, which means it's an increasing. So if we take a look here, ladies and gentlemen, here's an example where it's increasing as you go from left to right. Whereas if the base is between 0 and 1 and a is greater than 0, then we have what's called an exponential decay or decreasing. And that's this example here. So as you go from left to right, it's getting smaller. Okay? So here are your base functions for when the base is greater than 1. It's an increase or a growth. And if the base is between 0 and 1, so a fraction like a half or a third or 2/5, then it's a decay. Okay, that should be a quick memory from grade 11. Moving on, let's take a look at what a table of values looks like, and we'll give it a base function of y equals 3 to the exponent of x. Okay, so you don't necessarily need to write this down. We just want to discuss it carefully. Okay, so looking at this data point here, ladies and gentlemen, we've got an ordered pair. We have a table of values and the plots corresponding on the graph here. Notice, ladies and gentlemen, as I go from the bottom of this graph up, each time, if I look at my y values, they're getting a third less, a third less, a third less. That corresponds, ladies and gentlemen, on this graph, each time it's getting a third closer to what we call the asymptote. So if I keep expanding this graph, instead of 127, I could take 27 and times it by 3 and times it by 3. So the denominator will continue to grow, which means it's getting closer and closer to that intercept, but it's never crossing or meeting at it. It's getting very close though. All right. And when we have the growth here, folks, we have an increase here. How can you tell you have an increase? Because as you go from left to right, the numbers are getting bigger. And as you progress down, or as an increasing value in our table, the values of y get bigger. In fact, they're tripling each time. That makes sense, folks, because the equation we have is y equals 3 to the x. Now, ladies and gentlemen, you learned in grade 9 and 10 that in order to determine if you're given a table of values, if you have a linear relation, you would do the first differences, but we're not going to do them. I'm going to do something different. But you do the first differences, and you'd find that, hey, if they're the same, then it's linear. But in this case, they're not. So you would keep going, and you would do the second differences, and you would also find that they're not the same. But when you're dealing with an exponential, you're going to do what's called the y ratio. And the y ratio takes the value from the bottom and you divide the value of the top. So it would be 27 divided by 9, which equals 3. 9 divided by 3, which equals 3. 3 divided by 1, which equals 3. And keep going on. Remember, when you're dividing a fraction, you flip it and you'll get the the reciprocal of it. It'll still be 3. So notice that, ladies and gentlemen, these will all be equal to 3. That's the y ratio. Okay. So is this function linear? We're going to say no, because it is not a straight line. Or you could say different first differences, or first differences are variable. Okay. Second question, is the function quadratic? No, because you could say the graph is not a parabola. And you could say, because the second differences are not the same. Okay, for the finite differences, the values are a common ratio. And we call it the y ratio. So that's how you can tell from a table of values if your function is exponential or not. Okay, let's moving on. A little bit faster here. Here we go. Now you don't need to write this down initially because it's just a review of grade 10, but we're going to show you where we're heading. Okay, so in grade 10, when we take a look at a linear system, that's just two equations on a graph. The solution was the point where the graph crossed. So hopefully you would say P of I, which stands for point of intersection, would be 3 and 4. Okay, now we will solve for an exponential equation. And the solution is the x-coordinate of the point where they cross. So looking here, you could say P of I, now it's going to equal 2 and 9. So the solution here is at the 2. Okay? Any questions with that, ladies and gentlemen? Okay, let's take a look at another example. Now I want you to incorporate what we just talked about here into this example here. All right, so it says solve 4 to the x equals 16. Now, solution says this represents two equations, which are the first one, and hopefully recognize that as an exponential. Okay, I can recognize it as an exponential because it's got x as the exponent. And the second one is y equals 16, and that is a horizontal linear line. Okay, so today we're going to learn how to solve by graphing. In the next couple lessons, we'll learn how to do it algebraically. Okay, so graph each equation and get the x-coordinate of the ordered pair where they cross. All right. So first of all, if we take our table of values for the exponential, 4 to the exponent 0 is 1, 4 squared is 16, and 4 to the power 3 is 4 cubed, which is 64. So that I can plot like so. Okay. And then equation 2, ladies and gentlemen, doesn't really matter what I put in for that, because if I go -1, it's still going to be 16. I could go 0, it's going to be 16. I can go 116. I could go 1016. I'll just go 2 though. And 16, because in this equation, folks, it doesn't matter what my value of x is. Y will always be 16. So I draw a straight horizontal line with arrows at both ends. I apologize, I forgot my arrow down here. Okay, and then what we do, folks, is look for the point of intersection. So the point of intersection of P of I, and that in this case is 2 and 16. Okay, so what we then want to do is do what's called a check. Okay, so we're going to check x equals 2 in 4x equals 16. So remember, guys, when you do a check, you do a left side, right side check. Okay, what's on the left side? 4 to the exponent x. You sub in your x value, so it's going to be 4 squared, which equals 16. And the right side, it already equals 16. And remember your proper communication there. Since left side equals right side, therefore x equals 2 is correct. Okay? And if your values weren't the same here, folks, so say these totals were different values, then you would go back and check and see if you made a graphing error or an error in your check. All right, folks, here's your homework today. Page 66, numbers 1, 2, 5, 7, and 8. Have a great day, and in later lessons we will learn how to do this without using the graphing, but to do it algebraically. See you later, folks, and if you need help, come see me. Bye-bye.